So far, we've seen rules for products and quotients, taking the derivative using a product rule or a quotient rule, right? But what do we do when a function is within another function, right? So let's say we have y is equal to 3x squared plus 1, all of that to the fifth power. You could consider this as your inner function. Let's say we call that u. Right? U is equal to 3x squared plus 1. This could be considered an inner function, right? And then this fifth power can be considered an outer function, u to the fifth power, right? How do you take the derivative of an expression like this? In theory, you could just multiply this out, add all terms together, right? And then take the derivative of each one of those leftover terms, right? But that would be a very painful process, especially when you have access to something called the chain rule. All right. So the derivative of f of g of x is equal to f prime of g of x times the derivative of g prime of x. To differentiate a composition, right, you need to take the derivative of the outer function, derivative of the inner function, and multiply them together. That's essentially what the chain rule is saying, right? So let's do this with the example we had up above, right? Let me do that in blue, actually. Let's do that with 3x squared plus 1 to the fifth power, right? This would be equal to 5 times 3x squared plus 1 to the fourth power, right? Outer function here that we're taking the derivative of, right? Times 6x, right? This would be the inner function here. And if we were to simplify this out, this would turn out to be 30x times 3x squared plus 1 to the fourth power, right? And this would be your final answer here. Okay, what about maybe the derivative of, I don't know, e to the negative x squared? This is quite a famous expression, especially for integration, but let's try and take the derivative of this, okay? So this we can consider as our inner function, right? This is our inner function right here, and this e to the x as our outer function, right? So we can take the derivative of e to the negative x squared. That's going to be e to the negative x squared times negative 2x, right? And then that's just negative 2x e to the negative x squared. And that's the derivative of e to the negative x squared.